Good afternoon, good morning, everyone. How are you? Today, I will present to you on sample size determinations or calculations in a research survey. This will have the first lecture. I will proceed to continue on the future lecture 1, 2, and 3. So today I will present for you sample size calculations or determinations in a research survey. How to decide the sample size determinations for a right sample size in a research survey. So what is sample size? Sample size is number of pupils who participates in a research survey. These groups or pupils will be used to represent bigger populations and provide you with insights on the opinions, behaviors, characteristics of that large segment. Sample size refers to number of observations or individuals taken from a large populations for a research survey for the purpose of analysis. That is what is the sample size. What happens if our sample size is too small or too large? Let us see if our sample size is too small. Sample size small might lead to less label or bias results and wider confidence interval, potentially affecting the accuracy of conclusions. If our sample is too large, we won't have enough data points to draw useful conclusions from the research survey. So it will affect if it's too low. What happens if it's too large? A large sample size is referred when dealing with diverse populations or smaller effects that needed to be detected accurately. If too large, we could have, or the researcher would have, wasting time wastage, takes more resource, takes more data, takes more informations. So the data should be right and quite on good. In general, large population required larger sample in order to produce an accurate result. So large data is more time, takes more time and more resource. Small data is less reliable result and wider confidence interval and potentially affects in our conclusion. So our data should have more manageable and timely manner, and right sample size should be conducted. So what do you determine right sample size? We'll see in the future PowerPoints. Why is sample size is important? Sample size is very important. Larger sample size, as discussed previously as above, a larger size can potentially enhance precise of estimates, leading to a narrow margin of error. Narrow margin of error. In the other word, result from larger sample will likely to be close to the true population parameter. Large sample size increase the power of statistical test. So sample size allows the researcher to conduct their with a more manageable and timely manner. Random drawn sampling do not have much bias if large enough. So sample sizes, very appropriate sample sizes, very important. How sample size is determined? Sample size can be calculated or determined with the basic factors or the variables. The 4 variables. These are confidence level, margin of error, population variability, or standard deviations, the level of the significance. These are determined the sample size. These factors or variables determine the sample size. What variables or factors needed when determining the right population size? As I discussed as above, appropriate or right sample size is very important for manageable and timely manner and determining right size sample. So what are the variables? What are the basic variables? These are the basic variables. The first one is the population. The second one, margin of error. The third, confidence level and standard deviations. These are the variables or the factors that used to be determined our sample size in a research survey. So we will describe how these factors affect our sample size in a research survey. Let us start from our population size or population proportions. What is population proportions and what is variables and determined and calculated? Let us see in detail. Population proportion is a percentage of population that has a specific character. So one of the basic character is determined to be the population proportion. How many populations will be determined on the survey data? And what is the sample size to be determined? So there should be, we have to be conduct a proportion for a research or studies. So its value is 50% of the population. From different research shows that 50% of the population falls below the specific point and 50% falls above the specific point. So we have a specific character. From a specific character, 50% population falls above the specific point and 50% is below the specific point. So this is one of the factors that affect the sample size in population survey. The other one is designate our margin of error or confidence interval. This is very important one. The margin of error or confidence interval is a range of result that we are willing to accept when conducting a research. Its value is determined by the researcher or from literatures and measured as a percentage that is 0.05 up to 10%. A smaller margin of error increases the chance that our result will be close to that of the populations. Larger population, larger value will also far from the populations. Most commonly, 5% and 10% are used in the margin of error, that is E-value, or margin of error, or confidence interval. So, based on the confidence interval value, we first determined the value of P before to calculate the confidence interval. Value of P. What is the value of P and why P for 0.5 and P value? Let us see this table as shown on the left side. P means the percentage of picking choice expressed as in decimal or in percentage. Percentage of picking. Use 0.5 for sample size calculations. When the proportion in population is unknown for maximum population size. So we use 0.5 for population proportion, that is p-value, for unknown populations. That is to determine the maximum population size. Previous researches or literatures shown that value of P use 0.5. So why P for 0.5? What's the reason? What's the justifications P used 0.5? Look the table shown at the right side of this slide. As shown, there are table 3 columns and there are rows. So P represents percentage of picking and 1 minus P and P into 1 minus P. Look the value of P. P starts from 1 up to 0 and as shown on the column P, 1, 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2 and 0.1. So look the values of P into 1 minus P in column 3. 0.5 as shaded or shown on yellow color, 0.5, 0.5, 0.25. So the largest value on column 3, that is P into 1 minus P, is 0.5. So the highest value from this table is when P value is 0.6. Thus, we can see that 0.5 gives the highest value. So that is the reason we used 0.5 for value of P. Value of P. Then determine confidence level. What is confidence level? Confidence level is a percentage that represents how confident you can be that the true percentage of a population falls within margin of error. So the percentage of population that falls within the margin of error. So it will be determined from the value of Z or Z score. Z score is a value that determines how far a measured value is from a population value. So there is a Z score value table. On Z score value, we can determine confidence interval. Let us see the table, from the Z table to determine the confidence level. As shown here on table at the right side of this slide, Z value and confidence interval are shown or presented. Z score can be determined from confidence level using Z value tables. So, on the table column 1 and column 2, percentage confidence, that is column 1 as shown, and Z value on column 2. From column 1, confidence percentage starts from 80, 90, 95, 98, 99. On column 2, Z value, if the percentage confidence 80, read as 1.28. At 90%, 1.645. At 95%, 1.96. At 98%, 2.33. At 99%, 2.58. So the most common confidence interval, Z value, are 90%, 95%, 99%, and 99.5%. These are the most commonly. For our case, we use 99% percentage of confidence with the Z value 9.6 with 1.96. If the percentage confidence is 95%, we use Z value or Z score value 1.96. Let us see the above slide with the two basic formulas. These basic two formulas are very important to determine the sample size. In a population survey, so sample size for known populations and for unknown populations to be determined by these two basic formulas. And for unknown population or infinite population proportion can be determined by using Cochrane sample size formula. As shown on the right side, N, that is the sample size, Z, as discussed previously, Z value or Z score, P, we discussed previously, population proportion, E, margin of error. So from this, N is equals to Z square times P into 1 minus P over E square. This is Cochrane sample size formula. Cochrane formula for sample size determinations for unknown population proportion or unlimited proportions. So we will see this formula in examples. So Cochrane formula is due to unknown populations. If the population is unknown, we use this Cochrane formula, sample size determinations. The other one, for known population, if the population is known, we use Yeman's formula for sample size. As shown on the right side, n small n is equals to capital N over 1 plus capital N into E square. N means the sample size. Small n means the sample size. Capital N means the population size. E means the margin of error. Sorry, please consider here P means n. So p means n in this case. So n, capital N means the population size, small n means the sample size, and 1 plus E square E means the margin of error. Margin of error. Let us see in examples. Let us see with examples. Cochrane formula for unknown populations. As we discussed previously, n is equals to z square times p into 1 minus p over E square. This is Cochrane formula to determine the sample size for unknown population. Now plug these values. These values are discussed previously. Now p means its value is 0.5. This value is often pulled from researches or literatures, as discussed previously. Z score at 95% confidence level and 5% of margin, 1.96. E, margin of error, use 0.5 from the Z value as discussed previously in decimal or in percentage. So we insert this, or we plug these values into the Cochrane formula as shown on the right side. Z square 1.96 square times P 0.5 into 1 minus 0.5 over 0.5 square. It gives n value 385. Thus, maximum sample size will be 385 at 95% confidence level with 5% margin of error. So this is a sample example to calculate sample size for unknown populations by using Cochrane formula. Let us see Yeman's formula to determine the sample size for finite population or for known population. If the population is known, we can use Yeman's formula. As you have seen on the right side, small n is equals to capital N over 1 plus capital N into E square. Small n means, as calculated previously, 385, value calculated using infinite population formula. Z means 1.96 based on 5% margin of error and 95% confidence interval. P means 0.5, we discussed, and E means 0.05. Assume the population would be 1,000. This value will be inserted if known, if the population is known, and assume, this is an example, and assume if the population is known and if it is 1,000. And plug these values into the Yeman's formula, that is small n is equals to capital N over 1 plus capital N into E square. Substitute these values. Now 300, as shown on the right of the slide on the presentation, 385 over 1 plus 1.96 square times 0.5 into 1 minus 0.5 over 0.5 square times 1,000. It gives 279. Thus, we have 279 respondents are needed if the population is known by using Yeman's formula to determine the population size for finite populations in a research survey. So this is example 2. Now we can conclude. Generally, when speaking, calculating the sample size, it's better to use minimum absolute 300 respondent. It's also important that larger size sample size is more accurate your data and will be costly. And there is a point of diminishing return where adding further pupils to survey offers marginal benefit from the terms of the accuracy. It's also important that our sample size we choose will depend on the specific object of the research. It depends on the types of the research. It may be a medical research, it may be a social, it may be an engineering research. Whatever, it depends on the specific characters of the types of the research. And it is the best to consult with professional researchers and review more literature and research in order to get an appropriate number of particular populations. And it will be manageable and timely manner, and it will be a right sample, and it will be a right sample for free from bias. So this is the part one, an overview of sample size determinations or calculations in a research survey. I will come on lecture 2 with detail other examples and further calculations. If you like this video, please subscribe, like, comment, and share. Please don't forget to do this. Thank you very much, dear colleagues, dear listeners. I will come back with another video. Please subscribe, share, comment this video. Thank you very much. See you back soon.